What neuronal evidence supports the bias competition models of attention? Evidence for the bias competition model has been already observed at various levels, including the single unit recording of the neurons. And but still there are some uncertainty about how these small neurons firing gives rise to neuroimaging signals like EEG and fMRI, and also how does it relate to behaviors not 100% clear. And also many different kinds of attention and experimental situation happens as well. But most importantly, how it relates to consciousness is not yet clear. So the first of all, the model that I talked about in the last meeting is almost kind of verified at the level of the average of the neurons in the V4. So this is a study done by Reynolds and reviewed in the Quest for Consciousness. And essentially this figure summarizes this situation. The stimulus is presented briefly, and it's x-axis the time, and the y-axis is the firing rate of the recorded neurons in V4. And then when the good stimulus is presented alone for V4, then it produces strongest response, and the poor stimulus alone produces very weak response. And then if you present both at the same time, it's intermediate. But now, if the monkey, this is an experiment in monkey, attend to this good stimulus, then it recovers its very good response in V4. And if they attend to the first stimulus, then it becomes almost like per stimulus alone situation. So that's confirming pretty much the ideas that bias competition model predicts. And then something similar has been reported in various other experiments, and match, non-match task has been also used. And then here it's more complicated kind of condition where the match or non-match task instruction, so this is a top-down attention, is signaled by the central cue. So central cue is black or white. In that sense, there is a stimulus confound, but the stimulus confound at the level of recording doesn't exist, right? So here, the stimulus presentation frame is exactly the same, unlike the previous, John Reynolds experiment. So here, if you look at the configuration of the 6 things, they are the same. But monkeys here are attending to this white color. Or it's almost like inattentional blindness, white gorilla, white versus black team basketball kind of situation. And then they have to report on the orientation of the white stimulus later. And that's here, that's discrimination phase. And here, in this case, monkey has to say, make an eye movement to this one because it was presented at the same location and also same configuration and things like that. And then on the other hand, this non-match task situation is that they are looking at or paying attention to the black things. So here, black things are attended and then present. At the end, they make a sakar or something like that on the black thing. Important kind of idea here is that you measure the neural activity that responds to this white stimulus at the location that neuron has a receptive field. These two situations are identical from the neuron's perspective. What is different is that the monkey's strategy, memory, or attention to the white stimulus or black stimulus. And then as a result, what happens is this situation. When monkeys are paying attention to the matched color, then the stimulus B4 neuron response becomes much stronger, overall, right here. And then no matched color produces much weaker response. And notice that the initial response up to like 100 milliseconds is the same. So there is some kind of ongoing dynamics to explain what this attentional response means. Okay. All right. So the core principles of biased competition is that the attentional effects get stronger when the stimulus, in terms of stimulus, when competition among stimulus becomes stronger within their receptive fields. And in terms of the neurons, when the neuron receives many inputs, which happens more, higher hierarchy, right? And with a larger receptive field. And psychologically, when some biasing process operates during the task, such as instruction to pay attention to black or white things, or expectation, like in the case of change blindness, if you expect that car's window is going to change and so on, that's going to make a difference. And memory-wise, if you have memory of seeing this gorilla kind of demonstration, then that also guides you to attend in one particular feature, and then that brings those stimulus into consciousness. So the conscious perception can be drastically changed without changes in the stimulus. And then finally, what is the source of the attentional bias? And this can be done also, can be studied with simultaneous stimulation and also recording between the prefrontal cortex and the B4. So that's done in by the Moore's group in 2003. Here, what they did is to record from B4 neurons, which shows this attentional effect. So one electrodes are recorded, inserted into B4, and then they mapped out the receptive field to be here, and the monkeys are fixating at this location. And then they also found that this neuron has a tuning that it prefers the stimulus on the horizontal direction, like this one. And that produces a stimulus response like here. So when the stimulus is presented at this location time 0, and then neurons respond like this way, very strong after the stimulus onset. And then at the same time, critically, they also inserted the electrode to the area called the frontal eye field, FEF, or that is known to be related to the movement of attention, eyes as well as attention. And then what they found was that these particular areas of FEF, when they stimulate, FEF with certain duration and also strengths, then monkey's eye moves from here to there, okay, over the time. And that reliably induces eye movements into this location. So that overlaps with the B4's receptive field. And this is very important. So that means that when the FEF location around here is stimulated, then the monkey, either consciously or non-consciously, feels like they need to move the eyes over there. That means maybe they are attending. And then what they did really cleverly is to choose the stimulation duration and the amplitude so that it doesn't induce eye movement. So monkeys are still fixating at the center, but possibly providing some kind of input from FEF to the B4 subliminary without moving eyes, and then see what happens in the level of the B4 neuron spiking. And that's the idea of this experiment. And then what they found was the following. So again, to induce this competition, they presented a stimulus for both left side and right side. And then they recorded eye movements from horizontal and vertical direction. And then they made sure that there's absolutely no eye movements induced by this microstimulation here, right? And then visual stimulus for both inside and outside receptive field is presented. Initially, neurons firing here is the same with or without stimulation. But after certain time here, when they stimulated this FEF location, it's increased the firing rate of the neurons transiently. So that means that there is some kind of connection of the neurons from FEF to B4 that is usually related to the attention, eye movements, but even with a subthreshold stimulation that doesn't generate eye movement, it still increases the response of the B4 neurons. And that's sort of the neural underpinning of the source of the bias competition. Okay. So in summary, neuronal base of attention, in terms of biasing signals, they are likely to be coming from frontal or parietal cortex to resolve the competition. And then the key is overlapping the receptive field at the level of the higher visual areas, and they induces overlap. And then now the last question is that whether there is a theory of consciousness that is consistent with this idea and explain various phenomena.